Let's start our example. In today's session, we'll understand about the concept of SSIS package properties. It's all about the concept of different properties available in our SSIS. Let's get started carefully step by step. Here we go. Assume, for example, you have an SQL database with you, any database, or you may use TempDB or any database of your choice. You have a table like this: product ID, product name, and product size. 3 columns in the products table. And our requirement how to control the data insets using SSIS. That's our requirement. Case 1, insert data, or simply say store products. I'll say store products data independently. So 1 insert, 2 inserts, 3 inserts independently. Case 2, either store all products or nothing at all. And case 3, if few products are stored successfully, then next time we execute or we store only remaining products. You don't want to reinvent the wheel. You don't want to have duplicates. Let's understand the requirements and the solutions carefully step by step. First case, you would like to store data, just like insert statements, independently. Let's take the first case. So here is our notes. We come across something called package events applicable for control flow items. Here in any SSIS package, the task-to-task communication or connection is called precedence constraint. The task-to-task connections are called precedence constraints. Green, success; red, error; blue, on completion. This way. Green, success; red, on error; and blue, on completion, either success or failure. So examples to understand the package properties. Launch SSMS tool and connect to the database, any database, in our example TempDB, and you create a table like this one, with some check constraint for small, medium, and large products. First case, first requirement. So requirement 1, either, here it is, the success or fail. This will be the second requirement. Firstly, what we do is, first requirement, let's put this way: I launch SSMS, and once we launch SSMS, we are going to connect to TempDB or any database, create a table. Next step, let's continue. Requirement 1. Here it is. Store data independently means the success or failure of one insert will not impact remaining inserts. Okay, success or failure of one insert will not impact remaining inserts. That's our requirement. So what we do first, of course, earlier we launch SSMS and table ready, no data, just table is ready. Now launch SSDT, new project. In control flow, drag and drop, execute SQL task, file and new project, integration services project. I'll take something called as the package properties, click OK. Give integration services project, click OK. So in the control flow, let's wait for a few moments. Okay, so here we go. Go to control flow. Next, in the control flow, what we do, let's see. Drag and drop, execute SQL task. Drag and drop, execute SQL task this way. Okay, this one. New project, SSIS package. Then control flow, drag and execute SQL task, edit. So here it is, edit and connections. Right click, edit this one. Right click, edit. You get execute SQL task like this. Next, define connections to the server database. This one, drop down new connection, new connection. This is our connection, server database, click OK. Then we have SQL statement, click on SQL statement. So here it is. Give the SQL statement as insert, this one. Insert into table name values. Insert into table name values. Click OK. And parse the query. Click on parse query like this. Parse means to verify, check for the syntax. But parse will not work here. We need to say bypass prepare to false. Only then we can parse, verify the syntax. So query parse correctly, this one. Click OK. So this is insert product 1. Give some name. So insert product 1. Click OK like this. Just click OK in this way. Okay, next step. Copy the task. Copy the task and paste. Once again paste it. This way you'll paste it for total of 4 times. Right click, edit, second task. This will be for product 2. And SQL statement, this one. Give the SQL statement like this. And click OK. Same way. Okay, next, let's see. Right click, edit. Right click, edit. Get third product like this. Insert SQL statements. Okay. Insert statement. This one. Remember, it should be small, medium, large. I'm giving a different product here. And then click OK. Parse the query, check for the syntax. So syntactically it is valid, but runtime you see error because it violates the check constraint. Same way, edit. Right click, product, edit. Product 4 like this. SQL statement. Insert statement like this. Okay, give the insert statement in this way. Okay, next, let's see. It's a valid product, right? Valid value. Click OK and click OK in this way. Okay, next. With this information, so what we're doing now, yes, you get product 1, product 2, product 3, so on in this way. Okay, next. Here it is independent activity. So right click, add annotation means comment. Right click, add annotation. So far we just got the setup of 4 products, 4 tasks. Requirement, independent inserts. This is your package 1, independent inserts. Right click, package, execute. Independent means either 1 is success or 2 is success, nothing happens to 3. Everything is individual, no dependency. Let's wait for some time. Okay, next. With this information, Here 3 fails, right? Why 3 fails? Go to progress. 3 fails. Go to progress. Next. Once you go to progress, next step. Here you will see the progress. Insert into third product failed, right? See here, it failed. Statement has been terminated, something like this. Why? Because conflict in the database temdb table product size. So this is how you read the errors. Check constraint error. So 3 fail, but still because the tasks are independent to each other, 1, 2 and 4 were successful. Let's go to the source, or here it is, products. So package 1, independent inserts, output 3 rows, 1, 4 and 2. Order not guaranteed, they're all independent. Let's truncate the table so that we are ready for our next example. Second example, here it is, either store all data or nothing. Here it is, package 2, either insert all or nothing, means a single transaction. Output will be no rows. Let's see, either all or nothing. That's our second requirement. Store all products or nothing. Let's see back. Here it is. So first requirement, independent inserts. Now right click package copy, right click package copy, right click project paste, right click package copy, right click project and paste. Here you go. Go to project paste, and what we do here, let's see. Requirement would be either insert all or nothing. Insert all or nothing. Then what we do, let's see. I'll simply get the green box. This is called precedence constraint, the connectors. We call them as precedence constraints. This one. Here you see by default success, you see failure or completion also. For now, I'll take it as completion, like this. You see dark color. If it is, say, control Z, by default success. That connections are called precedence constraints. Back to our notes, this one. The task to task connections, dependency controls are called precedence constraints. Now, what we do, let's see. So you get them connected, then next step, get them connected, then next step. Right click package execute. Right click package, click execute. So here what happens? 1 and 2 were successful, but 3 error. In the progress bar you see why we have error, right? Check constraint. I don't want to resolve the error. Let's understand how the package we'll have this insert all or nothing. By default, it gets inserted. But our requirement is complete or nothing. So what we do, let's see. Our requirement, complete or nothing. I don't want to go halfway. Complete or nothing. Then right click package properties or right click control flow properties, either of them. Right click control flow properties or package properties. Here, scroll down, you see something called as transaction option. Make it required. Means you would like to execute the package in a transaction. Back to our notes. So here we go. This is the first package earlier. Now second requirement, either insert all products or nothing. Okay, so here it is. To control the package execution, we use something called transaction properties or transaction options. They are required, supported, and not supported. Three things. Required means to start a new transaction. Supported means to join existing transactions. Observe carefully. To join existing transactions. Okay, next. With this information, then we have other one. Not supported. Do not join existing transactions. Okay. Join existing transactions or do not join existing transaction. That's our requirement. So what we do here, let's observe carefully. What we do is right click package, right click control flow properties. Then we see something called package properties. Set transaction property required means to start a new transaction at package level. Use this option required. Here you go. Package level required. Remaining supported. Supported means they join existing transaction. Okay, next. So others leave it as it is. Only package level required. One more important thing. This is not enough. We need to go to run. Go to Windows. Run command. There we have to say services.msc. We see something called distributed transaction coordinator. Service should be started. Okay, we have to start the service. So here it is. What we do first? Copy paste above package. Then set success connection between the tasks. Do this one. Task 1, 2, 3, 4. Okay. Once you do these activities, then get the package transaction option required. Package transaction option required. Then also we need to have something called as distributed transaction, DTC. that service should be on. Okay, next. So what we do here, let's observe carefully. Once we start the package, then here it is. Execute package, verify the output. So initially, right now, the table has no data initially. Then what we do, first step for the requirement, first step, transactions, first package level required to initiate the transaction. Then go to services.msc. Remember this command. Microsoft Services Console. Go to this command. There is something called distributed transaction coordinator. You have to start this service. Otherwise, you get the DTC error. Start the service. Distributed transaction coordinator has to be started. Then right click package, execute. What's our requirement? Complete or nothing. So auto rollback in case of any error. You are aware of the SQL concepts, transactions. We are applying it carefully here. Transaction means complete or nothing. Right click package, execute. Any number of times you execute, same process. Automatic rollback occurs. You see green here, but go back to the table, we don't see any data at all. I mean, the task 1 and 2 got rolled back. So though you see green, they got rolled back because 3 has an error. That is complete or nothing. To set a package run in a transaction mode, number 1, the properties transaction should be required. Number 2, this service distributed transaction coordinator should be started. It initiates SSIS transaction. Next, first requirement, independent insert. Second requirement, insert all or nothing. Now let's go back to the first requirement again, copy the package. Let's go for the third requirement. In third requirement, if package fails, you would like to restart from the point of failure. If package fails, you would like to start from that point of failure only. You don't want to roll back everything. So requirement, if package fails, then for next execution, once you execute it next time, we need to get this started, get the package started, package execution started from point of failure. This is our requirement. If package fails, the next time we execute, start from the point of failure. Okay, so here we go. How to do that? Let's see. If package fails, the next execution, next time you execute, start from the point of failure. How? Here it is. Go to control flow properties. Go to control flow properties. Here, make sure package option should be supported. Leave it to the default. If it is required, again everything roll back. You don't want to roll back. If something goes bad here, Next time you start from that point of failure only, right? So whatever is success earlier is fine. Leave it. You have to start from the point of failure. So no rollback should occur in this requirement. So package properties should be left as it is. Don't say required, leave it supported. Now, here it is. Save checkpoint. Checkpoint is a property to track if package fails. If package fails, save checkpoint. Save the point of failure. Why? To start from there for the next execution. Here point means task. Identify which task fails. Start from that particular point. Checkpoint uses if exist. Checkpoint uses if exist. Observe carefully. Checkpoint uses if exist. Next. Here we go. Checkpoint uses if exist. Then checkpoint file name. Very first time checkpoint does not exist. If it exists means for the next executions. You would like to save the checkpoint file. I'll say checkpoint file. No need of any extension. One file would be auto created if package fails. Why? Next time we execute, it will start from that point of failure only. Remember. Next time execution will be from that point of failure. That is the actual requirement here. So what we do? Firstly, make sure we have this tasks requirement. Then next step. Right click package properties and checkpoint uses, or right click anywhere in the control flow properties. First item, checkpoint file, checkpoint uses, save checkpoint. That's the first step. Second step for this requirement, select all tasks, and we don't know which task may fail at what time. So select all tasks, fail package, on failure set to true. If any of these tasks fail the entire package. That is a requirement. Observe carefully. If any of the task fails, then fail the entire package. That is the meaning. Then what happens? First time you execute the package, it fails and a checkpoint file will be created. It fails and a checkpoint file will be created. You may go to the location and see here one checkpoint file got created. We can open the checkpoint file in a notepad and verify the contents, auto generated contents. Something like this. A checkpoint file will be created like this. Now 1 and 2 gets inserted. Checkpoint file is created, 1 and 2 gets inserted. Here it is. Checkpoint file will be created and 1 and 2 gets inserted. Here we go. I'll say package 3 in our example. If package fails, then restart from the point of failure. This is our requirement. So initially you see 2 rows. Output will be 2 rows inserted. And checkpoint file is auto created. Then what next? Here it is. Next time you execute, after some time you execute, next time only the remaining part of the package will be executed. Only the remaining part. What is that? From 3. Previously what happened? It is starting from the scratch, starting from task 1 every time. You don't want to have such duplicate execution. You would like to start from the point of failure. So what we do is now, let's resolve this error. Go to product 3 and here is the problem. I'll give some small or any other valid size. Okay, click OK. This one. Right click package execute. Remember earlier there is an error task 3. So from task 3 remaining package gets executed. That is the concept here. This is what checkpoint property means. So initial execution 1 and 2 were successful and now 3 and 4 were successful. In real world, when working with ETL environments, assume there are different data flow tasks. One data flow loads 1 million data. Second data flow loads 2 million data. Third data flow loads say 3 million data. Assume. What if second data flow fails? Next time you execute, if I don't set this checkpoint, what happens? That initial 1 million rows will be re-executed unnecessarily. Unwanted data loads. To avoid them, we have this checkpoint property. So what are the steps for checkpoint? Before that, here it is. So correct the error, then execute package again. You'll see 2 more rows. Checkpoint file is auto removed. Why? Because package successful. Only if package fails, checkpoint file would be created. Now checkpoint file is no more. Why? Because package automatically got executed successfully. So you got remaining rows. That is the concept here. And back to our notes for clarity. Earlier, complete or nothing transaction option required, right? And also Windows. So here it is. I'll put this way. So solution. So requirement and solution. I'll put this way. Solution. Step 1. Set package and get this way. This is step 1. Step 2. Windows run button, start the service. Which one? Distributed transaction coordinator service you have to start. Execute the package. So 2 steps were involved here, okay, for second requirement. Same way, let's have this package 3 requirement, this one. So requirement 3, here it is requirement 2. Now requirement 3, if package fails, okay, then continue the package from the point of failure. Here comes the concept of checkpoint. Checkpoint is a mechanism to audit location of package failures. Checkpoint file is auto created if package fails. It contains task information at which particular task the package failed. It contains the information of the task because of which the package failed. Okay, this one, package failed in this way. So next time we execute the package, it starts from this point of failure you see in the checkpoint. So what we do? Here it is. Once again, there are two steps for this requirement. Copy paste the package and set success connection between the tasks. Then right click anywhere package properties, save checkpoint to true, checkpoint uses if exists, checkpoint file name, give any file path, any file path is fine. Then step 2, for this requirement, step 2, we need to implement something called event bubbling. What does it mean? Remember, select all tasks, properties, fail package on failure set to true. This one. Select all tasks, properties, this one, fail package on failure set to true. Here it is. Default is false, make it true. So if any of the task fails, package itself fails. We are bubbling means escalating task failure to package failure. That is the concept here. So this, to implement package event bubbling, if any of the tasks fails, then package fails. Then what we do? Here it is. Execute the package, verify the output. Then step number 3, what we do? Yes, here it is. Step number 1, checkpoint. Step number 2, event bubbling. Verify the output. Task 1 and 2. Task 1 and task 2 will be successful. Now what we do in step 3, edit the package and correct the value in task 3. Then what else? Execute package. Now what happens? Task 3 and 4 will be successful. This is the concept. So first requirement, independent activities. Second requirement, complete or nothing, right? Complete or nothing. Then third requirement, if package fails, restart from the point of failure. That is the concept. So here we are understanding, in this example today, we are understanding different properties of the package, like transaction properties, checkpoint properties, event bubbling properties, and editing the tasks, controlling the precedence constraint, independent, dependent, rollback, and partial executions. We are going to use these properties in our next upcoming concepts. So you practice this important feature or important example set as is to get ready for the next examples. With this, we'll stop for now. You'll practice these items carefully and use me for your doubts and clarifications.